Okay. Good morning, everyone. How are you doing today? I feel rested. I hope you are rested as well. We want to welcome you to the National Mathematics Program series of CSEC workshops in Region 1. We are a team of about 8 persons, and we are here to guide you. We have had 2 days so far, 2 good days, I think. First day we did coordinate geometry, and then yesterday we did statistics. Today we want to look at the introduction to trigonometry. Our presenters are Mrs. Tamika Lodge Fenton and Mr. Giovanni Limi. They will guide us through the presentations today. You know the material that you need, but I'll just remind you, you need your math notebook. You need paper and pencil, pen and pencil, of course, for writing. And again, you will also need your calculator. So make sure you have those ready. If you don't have your calculator, run and get it. We will wait for a little while, continue the introductions while you go and get your calculator, your math notebook, and of course, your writing instrument. We are looking forward to an engaging and session where you participate. We want you to be doing the activities. We want you to be talking open your mic and unmute and talk. We want you to type in the chat if you want to respond to a question, or if you have a question of yourself. Let us know how you're getting along with the presentation. So talk to us, chat, type in the chat. We want to hear that. All right, the 3-day presentations, all 3 days are available on our YouTube channel. And we ask that you use that as part of your revision, right? We are 3 weeks away from exam, just about 3 weeks from exam. So use the presentations on our local chat, on our YouTube channel, which we will paste in the chat as part of your presentation, and encourage your friends to go on, right? At the end of the morning session, we usually ask you to evaluate the session. Remember to stay for that. And we come back in the afternoon at 1 o'clock to look at some exam type questions. So I hope you've gotten your calculator and your notebook ready. I'll now hand over to our presenters for the morning, Mrs. Tamika Lodge Fenton and Mr. Giovanni Limi. Have a good workshop.
Good morning, everyone. Oh, let me just mute this. All right. I am Tamika Lodge Fenton. Oh, let me let you see.
And I am Mr. Giovanni Limi.
Okay. Oh. I'm going to open my camera so you can see me. Are you seeing?
Yeah, we are seeing.
Tamika Lodge Fenton. And as you can see, Giovanni Limi. I'll be closing my camera so that the presentations flow smoothly. So just bear with us.
All right. So today's session will be focusing mainly on the topic of trigonometry. So let's just do a short objective of what we plan to do for today's session in brief. So the Pythagoras theorem, In today's lesson, we'll be looking at how we can use the Pythagoras theorem to identify the length of the sides of a triangle, right triangle, and when can we actually use this Pythagoras theorem when we're solving real world scenarios or real life problems in that sense. So before we begin, I'll just do a quick or short review, very short. So this one. So let's review. So we have a triangle right here. And this is, of course, a right triangle. Can anyone tell me in the chat why this is a right triangle? Can anyone in the chat tell me? You can type in the chat.
Because it measures 90 degrees.
All right, it measures 90 degrees, right? All right. So that's a little 90-degree angle that we refer to. So that's 90 degrees, right? So it is called a right triangle because it has a right angle, as you said earlier, Mr. Campbell. So what do you think is the measure of this angle? We just said it really and truly, which was 90 degrees. All right. So that's still to short review about the right triangle, namely being that it has a right angle in that triangle. So did you know that about 2,500 years ago, a Greek mathematician named Pythagoras discovered a special relationship between the sides of the right triangle. And remember that a triangle has 3 sides. And for this specific one, we have special names, which we'll be expounding on a bit.
So just to add to that, not only did the Greek mathematician named Pythagoras discover this special relationship, but in Egypt, this relationship was discovered and was being used for many years before, just to let you know. But Pythagoras is the one who noted it in history and put it out there for us to use in math all across the world.
All right, thanks for that, Mrs. Lodge Fenton. All right, so quickly moving along. So Pythagoras realized something somewhat special about a right triangle, or in other words, a right angle triangle, if we might call it that. So again, this is a right triangle. And you notice we have some numbers associated with this triangle, namely 3 units, 4 units, and 5 units. Now, if we actually square the lengths of the 2 sides that make the right angle, which would be the 3 units and the 4 units, as you can see, the 3 right there and the 4, which are the 2 shorter sides, if you notice that much, in this right triangle. So if we add the squares of these 2 other sides of the right triangle, we get 3 squared added to 4 squared, right? So that's in a nutshell. And you realize that we get the same number that we would get if we actually square the other side, or the last side, because we had 2 sides and we have 1 more side, which is 5. So if we square them, 3 squared added to 4 squared is equal to 5 squared. Again, that's the other side that we want, which is highlighted on the diagram that you see on the screen right now.
Giovanni, let me just add there. So remember, Pythagoras realized that there's a special relationship among the 3 sides of a right triangle. The right triangle meaning that at least one of the angles has to be 90 degrees. So if you look here, we have the units are 3, 4, 5. And if you were to square the length of the sides, it would equal the square of the longest side, right? All right, continue. You can go ahead, Giovanni.
All right. Thanks much, Mrs. Lodge Fenton. So let's now actually somewhat dissect the lengths of each of the sides of this triangle. And we're going to square each of the dimensions. So again, we had 3 units, 4 units, and we have 5 units. So would this be correct? Now, I'm actually finding, can anybody tell me what I'm actually finding in the green figure below? Can anyone type in the chat what we're finding in the green figure below? Can anyone tell me? You can open your mics if you wish to do so, or you can send that message in the chat, whichever one you choose. Okay. Mrs. Fenton, could you read that response in the chat for me, please?
Sure. The unit of the bottom part. It looks like a question though.
Oh, okay. Anything else in the chat? Okay, I see one more response. What's that response say? And any one of my colleagues can drop in or time in if you wish to assist me with deciphering the chat messages.
Units there. We had 3 units at the base of the triangle, one of the shorter legs. When you see that 3 by 3 square, what do you think is representing? All right, someone says, Chanel says square root of the bottom unit. Chanel, you're on a track. You're on a good track there, but think about it. What is the square root of something? when you find the square root of a number, what are you looking for? Is it the square root? So remember, the relationship is we are looking at the square of the sides. So when you square something, remember the original unit was 3. So we pretty much drew a square using the dimension 3. So it's a 3 by 3 square. So Shanila, though you started off saying the square, and then you added the root, it's not really the square root, it is the square. So we have squared the length for that leg of the triangle. Continue, Giovanni.
All right, so when we square that 3 units, we're basically finding how many square units it is, but we'll continue later. So as you can see, the orange shape or the orange square, it's 4 units, and we decipher that a bit, likewise with 5 units, right? So now we see that we have the 2 smaller sides and we have the larger side in the blue. So let's now find what we call the area. So that is what we're actually trying to find. We're trying to find the area in a nutshell. In other words, 3 squared. If I do 3 squared, or I find how many unit tiles, or how many square units, sorry, I have in the square below, I'll have 9 units squared, right? And how much do you think would be in the orange square? Can anybody tell me in the chat? How much unit square would that be, or square units? How much would that be? In other words, 4 squared, 4 multiplied by 4. How much would that be?
I see, Deshanti says 4 square. Okay, great. Shay says 16. Janae says 16, and something. Kayulani
Right.
also says 16. Great job, guys.
All right.
So, yes.
Let's just do that. And we indeed get the 16. And can anybody tell me what the last one would be, the blue square?
Well.
How much would that be, the blue square?
So we're looking at the longest side now. What would and Shay says 25.
All right, 25, that's actually correct. So 25 square units, right?
25.
All right, fantastic, good. So we're actually squaring each of the legs of the triangle, the right triangle, right? So we had 3 squared, then we had 4 squared, then we had 5 squared, respectively. So now, if I look at this now, what would this represent? I have the 16, 9, 25. Does anybody notice anything in that sense?
In other words, can you guys see a relationship with all those 3 sides? Can you come up and tell us what is the relationship that exists right there? You can type it in the chat, or you can feel free, open your mic. I'd like to hear some of you.
Yeah. Anything in the chat yet?
They are all square numbers. Excellent, Deshanti. They are all square numbers. But as I said, the relationship that exists with all 3, how are they related? How are they affecting any other? How are all 3? I'm trying to not say too much. So you see me picking and choosing my words. But the 3 sides, we already stated some facts in the beginning of the presentation. I just want you to see, look at the 3 values you have there. You have 3 squared numbers, 9, 16, 25. How are those 3 numbers related? And it would help us to figure out what is the relationship with all 3 legs.
All right, nothing in the chat so far? All right. No.
All right.
Mm-hmm.
Nothing in the chat.
All right, cool. So if I actually added the 2 smaller areas, and the 2 smaller areas would be, what would the 2 smaller areas be in this triangle? Can anyone tell me in the chat? Anything at all? What would the 2 smaller areas look like? What is the actual number associated with those 2 smaller areas? All right. Mrs. Fenton, Lodge Fenton, could you tell me that what's in the chat so far? Because I started to message.
Deshanti, there are also numbers 16 and 9. What was your question? It said they're answering 16 and 9.
All right, 16 and 9. So if we add the 16 and the 9.
Is it because Shay is asking, is it because 16 and 9 are on the shorter side?
Well, they're the two smaller areas. Remember that we have three areas. We have 9, 16, and 25. So the two smaller ones would be 16 and 9. And if you notice, the larger one is 25, which is always the longest side in that sense, right? So if we add the two smaller areas again, 16 plus 9, we get 25, right? And that's what we see in the blue square right here. So when we add the 16 and the 9, or the orange square added to the green square on the diagram that you see on the screen right now, you get the blue square, which is 25, right? And that only happens. Can anybody tell me when that happens? When can we actually use this? When? Can anybody tell me?
Said that it was 25. So Jenny had stated that, I guess she was in response to the 16 plus 9 gives us 25. Right.
All right. Can anybody tell me why can I use that this theorem, Pythagoras theorem in this case? When and why? We alluded to it earlier. So let's see what the responses would be like.
You can ask just a little bit different for us.
Okay. Can you repeat that one, Mrs. Lodge?
You can ask the question just a little bit different. What the question that you're asking? What are they supposed to answer again?
Oh, sorry. So we have the 16 added to the 9 is equal to 25. So what in this triangle would we associate with actually using this summation, if you want to call it that? Okay. Or adding the 16 and 9 to get 25. What in this triangle would signify that we should do such an operation or do such operations? Can anybody tell me the chat? No. All right.
Okay.
All right. I saw one response.
Okay, when the length of the hypotenuse is unknown. When the length of the hypotenuse is unknown.
Not quite.
The Shante is saying this can be used when you do not know that the length of the hypotenuse.
All right, but that's half there in that sense.
I think that's fair.
All right.
Good job, the Shante. I think that's a good try, of course. So what you're saying is if you have what? The Shante, you might don't work there. I like having a conversation with people, you know. Shante. Not a word. All right, so we're saying if you had the length of the two shorter sides, you could definitely find the hypotenuse. Good job. All right.
So it turns out that this is always true when we have a right angle. And if you notice, we have a right angle. It's a right angle triangle right here, that little blue square, the small blue square in the triangle. That's the right angle. So we can only use the Pythagoras theorem when we have a right angle triangle, right? It has to have a right angle in that triangle.
So guys, I think we were a little bit unfair with asking that question, because what we probably should have done, Giovanni, we should have given them another triangle that was a right angle and let them see the relationship among those sides. So we're going to pardon you this morning because we did not give you that comparison. All right.
All right, fair enough. So now the Pythagoras theorem basically states that once we have the sum of the squares of the legs of the right triangle, it's always equal to the square of the hypotenuse. In other words, we had the two shorter sides, which would be the 9, which we got from 3 squared, added to the length of 16, which we got from 4 squared. And that's equal to 25. Or in other words, the square of the hypotenuse, which we did earlier, which was 5. So again, that's 9 added to 16, the two shorter sides of the right triangle is equal to the hypotenuse squared. So again, the sum of the squares of the legs of the right triangle, two shorter sides, is equal to the square of the hypotenuse. So in general, we normally have an equation that we normally follow. So this is the equation. So we have a squared added to b squared is equal to c squared. And c will always be the hypotenuse, right? So when you take the sum of the squares of the other two sides, or the shorter sides, it will be equal to the hypotenuse squared, right? And that's the general formula or equation that we use when we're doing Pythagoras theorem. Only when we have a right angle in that triangle can we use the Pythagoras theorem. So we're going to go on to some activities in this sense when we're going to actually try to find the missing side of a right triangle. There are two scenarios. So anytime when we actually need, or we have been told to find the missing side of a right triangle, we can generally boil it down to two scenarios. Well, one of two scenarios in that sense.
Right.
So scenario one, when we have both legs and we need to find the hypotenuse. So we have the two shorter sides and we need to find the hypotenuse, which is the longest side of the right angle triangle. And then we have scenario two, when we have one leg and a hypotenuse. So one leg, it can be any one of the shorter legs, just one, and we have the hypotenuse, of course. And then we actually need to find the other leg. Remember that we have three sides of a right angle triangle, or we have three sides of a triangle in general. So now I'll hand over to Mrs. Lodge-Fenton as we go into the different scenarios, the types, the different activities that we can associate with those two scenarios, and we'll press onwards.
All
So,
right.
Mrs. Tamika Lodge-Fenton.
Thank you so very much. So here we are, and we stated that Pythagoras theorem can be used in one of two scenarios. So scenario one, what are we trying to find here? So I need you to either open your mics or you can type in the chat. What is missing? What are we trying to find?
Shay's hand is
Whose hand?
Shay.
Oh,
Shay.
hi, Shay.
The hypotenuse.
The hypotenuse. And I see Deja, what's that? Dejay is also saying the hypotenuse. Thank you. Thank you so much, Shay, for opening your mic. I really appreciate that. All right, so we are trying to find the hypotenuse. All right, and what is the letter X is there to show us that that length is the hypotenuse. Continue. All right, so the first thing that we want to do whenever we're working with Pythagoras theorem is to remind ourselves what is the relationship that exists with the three sides of a right angled triangle, right? And when we do that, we write the formula down just to remind us. So it's a squared plus b squared equals c squared, where c is the hypotenuse. So the relationship, the square of the two short legs, when summed together, will give us the value of the square of the hypotenuse. Good. So let us substitute the values that we have here. So we're going to plug these things in. So A, does it matter before I move on? Guys, does it matter if I use 15 for A or 8 for A? Open your mic. Shay, you know I appreciate you opening your mic. Dejay, feel free. I'd like to hear your voices. Okay, Deshanti, thank you. No, it doesn't matter. All right, what say anyone else? One more. Can I get a voice out there? You guys, you can't be like that, you know.
No, it doesn't matter.
Awesome. It doesn't matter. Great. So because it doesn't matter, we can plug in any of the values, the 8 or the 15. In this case, we're going to use the 8. So we have 8 meters representing one of the A, and we have 15 meters for the B. So let's plug that in. And of course, we're going to change the C to X because the hypotenuse is represented by the X. So I'm going to ask you now to work it out before we go any further. What is the value of 8 squared and 15 squared? You can type it or you can feel free and talk to me.
And I also have a calculator that we can use to.
All right, great. Pick up the calculator, and before I put any other value on the screen, and then we'll work it together. But I want to see in the chat, or you know I love to hear your voices. Tiana, I don't hear nothing from you from morning. What's going on?
Oh, I need to get for the calculator. Sorry.
Yes,
yeah.
please. All right, guys. So I need you to give me the values for 8 squared and the value for 15 squared. That's what I need to see in the chat, or you can open up and talk to me. All right, we have our calculator right there.
All right. So it
No,
was 8 squared.
Oh, no, you're not telling them nothing. I'm giving them some time. I'd like to see at least one response before we do anything. Come on, guys. We're not spending too long here.
It was 8 squared added to 15 squared.
I want them to give me the value for 8 squared first. We can do the adding. The value.
And ensure that your calculators are on degrees. That capital D that you see in the middle of the calculator, at the top of the screen, or to the right side. It must not be in radians or rads or the letter R. It should always be in D to get a correct answer.
Right. So I see Shay have 64 plus 225. All right. All right, I did say at least one, so I'm going to move on. All right, so Shay, can you open up and tell me what you did to get the 64? Dijon, I see you have 17 meters. I'm not sure what the 17 meters is, but we had the value for A was 8, and the value for B was 15. Oh, you're giving me the answer. I cannot believe you. You're giving me the answer. That's not what I asked you, but good job. All right. So Shay, right. Shay, you see what you did there? Okay. So what did you do, Shay, to get the 64? Just tell us. I just want to make sure everybody is on the same page, because using the calculator is a skill. Yes. Go ahead, Shay.
Because it says 8 square, what I did, I times 8 by 8 and I got 64.
Excellent. And same thing for 15 squared. Right?
Yes.
All right. Okay, and that's perfectly fine. That is squaring the number. However, there is another function that is on your calculator that we want you to know that you can use. Go ahead, Giovanni.
Oh, the square root sign, or should I just do the 8 squared?
Right, so 8. So you can press 8.
And then you see this function that says x to the squared.
Right, and you see what happened?
So 8 squared gives you 64, right?
Giovanni, put it in rad and see what happens, and let's show what happens.
It won't change much for this calculation.
Okay. All right. What about if we had put the squaring first?
The squaring first?
Yes. So take out the 8 and see if anything happens. So
all right. So
not the square root. Sorry, the squaring.
Okay, square. And then I pressed 8. That's what it gives me. So it says 0 squared multiplied by 8, which is 0 on this calculator. So every calculator is different. You must know how to use your particular calculator. You can't just borrow somebody else's calculator unless it's the same calculator as the one that you were using before. So you must be familiar with your own calculator, not one, but just even 2 calculators. Maybe 2 of the same kind or 2 different ones. But as long as you're familiar with the use of the calculator, you should be quite fine in calculating all of these values that we will be doing in this session.
So guys, point to note. Okay, point to note, as Giovanni said, you have to be familiar with the calculator you're using. Some calculators.
Yeah, some calculators would give you different answers, and we always need to have it in degrees and not radians unless you're told otherwise. But for CSEC, we always use degrees, right? All right, I'm going back to the presentation now.
All right. So here we are. So now that we know how to square the numbers, we can definitely move forward. So we have 8 squared. It's 8 multiplied by 8, 64, 15 squared, 15 multiplied by 15, 225. We sum that. That means we're adding it. We get 828, I don't know how I get 8. 289, and that is equal to x squared. But is that what we want to find? What's his name? What's his name?
Campbell, Mr. Campbell.
Mr. Campbell, who had worked.
So Mr. Campbell, why are we actually finding x squared? What are we actually finding? And anyone else can chime in for that response. What else are we finding?
Well, I told them.
What should we actually find? Oh,
I just told them. I
Oh, I
just
never
told them
heard.
that we are aiming to find x. Yes,
All right.
the question did require us to find x, the value for x, not x squared. So we continue. Right? Good. So we have found x squared, but we really want to find the value of x. Go ahead. So how do we do this? Before we even go any further, how do we solve? Well, we are going to use what is called the square root. And Chanel, I remember initially Chanel had spoken about the square root of something. This is where the square root is going to be used. So we're going to find the square root for x squared. That's because the square root of x squared will give us x. But as you know, when you learn concepts in math, it is brought forward. If you are using an equation, to balance the equation, whatever is done to the right side must be done to the left side, vice versa. So since we're finding the square root of x squared, we will definitely have to find the square root of 289. And that gives us 17 meters. So the value of x is 17 meters.
And remember, always remember the units once you get the. So always remember the units. So we were working with meters for the dimensions of the triangle, the right triangle. So we should always have meters once we get our final answer, which you see right here. So x is 17 meters.
Right. All right. So we went through that and we walked you through it. So now I'd love for you to be able to, let's go. Do one on your, let's see if this is the one that I want them to do on their own. Continue.
But first, let's do a summary.
Okay.
Scenario 1.
I'm not working them yet. All right.
All right. So I'll just do the summary briefly.
Sure.
So for scenario 1, what it really boiled down to was that we squared both legs, right? The both legs that we squared were the shorter sides of that right triangle. And then we add them together. So once we had the square of both legs, we add them together. Then after that, we took the square root of that result, right? And then we have our hypotenuse, which we actually wanted in scenario 1. So again, scenario 1 is when you have the two shorter sides and you need to find the hypotenuse, right? So again, you add the square of both legs, then you add them together, then you take the square root of both sides. The reason why we do for both sides is because we have an equation, an equal sign. So whatever we do on the left side, we do on the right side, which would balance our equation. If you do chemistry, you might have done some balancing when you have done CSEC maths, CSEC chemistry, my bad. But Mrs. Lodge Fenton will continue with the activities right now.
Okay. So here we are. It's a similar triangle. And of course, I know, what's his name? Mr. Campbell? You're just booming to get the answer out to me. You can DM me because I like to have a discussion before we put the answer in. So work this out on your own and then we'll go through it. So you can definitely put your answers in the chat. Put your answers in the chat. You don't have to DM me. Go ahead. Tell me what is the value of x. If you're given this right triangle, what would the answer of x? I would love to see the Shante. Okay, great. I'd love to see you working out. If you can take a picture and put it in there, but if not, I'll be all right.
And not just the final answer, we actually want to see what was your thought process.
I did want.
Yeah.
I would love them to take me a picture of what they did, but you know.
Before we move on.
Didn't want to push them too much, but yeah, I'd like to see that.
Not seeing any responses in the chat as yet.
Deshante had sent me a message.
Oh, okay.
Yeah. But I'd love to see, I'd love somebody to just take a picture of what you did. Especially if you're on your phone, just take a pic and share it with the group. Or you could even type it in there. You could just type in the 3 lines because it's really just plus and equal signs we're using. So you don't have to write in the squares. You could just work out the squared function. Who is that? Malik Johnson, hi. Welcome. Hi, Malik. If you are comfortable with opening your mic and walking us through it, you can also do that. You can raise your hand and we can definitely have that. We're going to move on in about 30 seconds. All right, the Shanti is putting in a group. Awesome. So you did that. Okay, that can't be the only thing, you know. It's not the Shanti, sorry, it's DJ Campbell.
Campbell.
But that, okay, all right. All right, square root for that. Get you that. All right.
And Shay said it right there, square root 169, which is the total.
Right,
or the
gives you.
of the 2 shorter squares. The squares are the 2 shorter sides.
I'm loving it.
All right, and remember, Shay, you have to have your units. So you just had 13. We're working with the units of meters, as Mr. Campbell has. He has 13.
She have it. She said,
Just
sorry.
Yeah. All right.
Awesome job, guys.
I think
All
we
right.
can continue to our working out now.
Yes, so let's look at it together. Very good, guys, and I appreciate you adding in the chat. This only makes it better for us to present when you are participating. Awesome work. All right, so we're here finding x. Go ahead. So, of course, we would want to start with our formula, which is a squared plus b squared equal c squared, where c is the hypotenuse. And as you can see, you sub the values in. 5 meters for the a value, 12 meters for the b value, and x for the c value. And we work them out. We would have shown you already how to use a calculator, and we hope that you are pretty aware and clear. If you do not have the function x to the squared power, you can definitely multiply the number by itself. So 5 5s, 25, 12 12s, 144, and we equal that to x squared. All right, now we don't want to find the value of x squared, we want to find the value of x. So the opposite of squaring a number is to find the square root of it. So we found the square root of x squared gives us x, and obviously we'll also have to find the square root of 169, which gives us 13 meters. Just a point to note, guys, if you are working, it would be nice, you can keep the units in your working out. You can, just in case you think you may forget the unit at the end. We know we're working with meters, so we know the value must be in meters. But if you think that you may forget, you can always put it in. So you could have 5 meters squared, 12 meters squared. You can always go that route. Okay, continue.
I think Chanel wants to say something.
Sure.
Oh, cool, sure. She can go ahead before I speak. Chanel?
No, it was, oh, Chanel, go ahead.
Yeah, Chanel. I thought it was Chanel, Mrs. McDonald.
I thought it was Hazel.
Oh. Hazel, you had said something? That someone wanted... Oh.
I think Chanel wanted to say something.
Oh, Chanel.
Okay. So could you unmute?
Not hearing anything? All right.
Oh, hold on. Something just opened. No, her mic isn't.
All right. One more thing before we continue. Some calculators are different, which I'll highlight right now. I'm trying to get that calculator up. Let me get it for you. All right. Everyone is seeing this calculator, right?
Yes, sir. I've seen the calculator.
All right. So I'm going to clear that value. So some calculators, you literally have to press number that you want to square root first before you can get an answer. For example, if I just write, where is it? Where is my square root sign? Where is my square root sign? Okay, this one.
It's right there. It's
All right,
beside
so
1 to the x.
yeah, I see. So if I click on this and I type in 169, it gives me this answer, right?
That's not the square root answer.
Oh, where is it? I never saw it. Where is it?
The second
Oh,
from
this
the
one.
front.
Yeah, this
Yes,
one.
right
Sorry,
there.
my bad.
Yep.
My bad.
So go
So
again.
169. So you press this symbol and then you say 169 equal. You notice you don't get any result, right? So in essence, what I did for this calculator, I inserted 169 first, then I inserted that square root sign, and it gives me my correct answer, which is 13. So depends on which calculator you're using, you have to do that procedure. Write the number first that you want to square root, and then you press that square root sign, which gives us 13.
I think that I noticed the ones that require you to put in the square root first are the ones that have a display. So when you see the square root come up on the display, usually you put in the square root sign first and then you put the number in. The one that don't have a display usually require to put in the number and then the function.
All right.
All right, a question here for the calculator. I noticed that there is the square root sign, and then there's another sign beside it with a little 3 beside it, and then one that with the y beside it. So the signs are different. One would be the square root because the square root is the one with the 2, the little 2 beside it. The other one would have been the cube root that we are not doing. So you have to, what I usually tell my students is that you test with something that you know already. So like, for example, we know the square root of 69 is 13. I would try to find the square root of 69 using the key function, by pressing the key. If it comes out to be 13, then I know it is the right key. You might want to remember that 5 squared is 25, and you test the calculator with that before you proceed so that you know it is the right key. Check with something that you know. That would be my suggestion here.
All right, awesome stuff. Thank you so very much, Mrs. Darby. So you realize that not only can you find the square root, but you can also find the cube root. And there are other roots of a number that you can find. And the functions are there in your calculator. So once again, familiarize yourself with your calculator. I got everything?
Yes, it did. We can move on.
Right.
Yeah, we can move on.
All right, move on. Awesome stuff. All right, so we have scenario. Remember, we just did scenario 1 when we are given the 2 shorter sides and we want to find the hypotenuse. So let's look at scenario 2. And if you're following, I know you're running this through your head and you're saying, oh, Pythagoras theorem is like just so easy to get. All right, so here we have the hypotenuse, and we can always identify the hypotenuse because it's always opposite to the right angle. So it's just that simple. Once you see your right angle, the side that is opposite to it is your hypotenuse. So we have the hypotenuse and we have one of the shorter legs. So we're asked to find the other short leg. And that's pretty much scenario 2. What do we do here? Continue. We just pointed out what we have. Okay, and we know this, one leg and the hypotenuse. Go ahead. What do you need to determine? And we said this, we are trying to find the other short leg. All right, let's move on. So of course, you always want to remind yourself of the relationship the 3 sides have in a right triangle. And that relationship says the square of the 2 short sides added, or the sum of the square of the 2 short sides, is always equal to the square of the hypotenuse. And the hypotenuse is always written, well, mostly written with C, but it doesn't have to be. All right, so here we are, and we substitute our values into the equation. So we know that one of the short side, we're going to call A 10 today, and B only stands to reason that it's going to be B. And of course, the hypotenuse, which is C, is 26. And we're squaring all sides and showing the relationship. So 10 squared plus B squared is equal to 26 squared. Let's do some calculation here. So let's work out our squares. 10 times 10, that's the same as 10 squared, which is 100. Can't do nothing with the B squared, we will keep it the same. And 26 multiplied by 26 gives us 676. And of course, remember what I said, if you want, you can always use your centimeters in your working out so that you remember the unit you're writing in. All right, continue. So now we are trying to find B squared. Look at that. So we want to, and I'm sure you've heard this term, we want to transpose the equation, making B the subject, right? We're going to transpose for B. So we have plus 100. What is the opposite of adding 100? We will subtract it. So we're subtracting 100 from both sides of the equation. So 100 from 100 gives you 0, leaving you with B squared. And 676 subtract 100 gives us 576. Continue. So here we are. We have B squared is now equal to, that should be 576. And the square root of that is, so let's make sure that we have the correct square root.
Let's let them work that one out first.
Right.
The square root of 576, what would that be? 576 centimeters squared.
Shay says it's 24 centimeters.
All right. Anybody, 24 meters or 24 centimeters? I never heard that one.
Shay put it in the chat as 24 centimeters.
All right.
Wait, miss, 676 minus 100 doesn't give you back 676. It will give you 576. And then when you square it, you get 24.
All right, cool, nice. So that was a little error on that side. So that would indeed be 576 centimeters squared, and you square with that number right there. And you get 24 centimeters as Shay just highlighted. Everyone is okay? Everyone is good? Everyone knows how to use a calculator a little bit better now as it pertains to square root and squaring numbers. No response? I guess no response is good. All right, yes, okay, nice. All right, so now let's look at the summary of what scenario 1 and scenario 2 would be. So in essence, yes, Mrs. Lodge, Mrs. Tamika.
No, but you can move on to the next slide.
All right. So for scenario 1, when do we add? That's when we have scenario 1. Because when we have both legs and we need to find the hypotenuse. So again, in scenario 1, what we did, we added, then we found the square root of that summation or summing or adding of the two shorter sides, the square of the two shorter sides. And then if you notice in the scenario that we just did, which is scenario 2, that's when we actually subtract. So scenario 2 is when we subtract, when we have one leg and the hypotenuse, and we need to find the other leg. So that's the difference between when we need to add and we need to subtract. And obviously it would have some form of square root that we need to actually calculate to get the actual answer, the final answer. Remember, we don't want any x squared, y squared, c squared, a squared, b squared. You want the actual value once we find the square root of that. So that's how we explain those two scenarios right there. And Mrs. Lodge Fenton will continue with the other questions. Okay, she's not here right now. So on to task 2.
I am so sorry. I couldn't get to unselect the mute. Sorry, I'm sorry about that. All right. So task 1. Go ahead. Okay, so we have a rectangular field and it has a length of 100 meters and the width of 33 meters. So it's 100 meters and a width of 33 meters. About how far is it from one corner of the field to the opposite diagonal corner of the field? So before we go any further, I'd like you to sketch. Now, how many persons can just sketch it on and take a picture of it?
They don't have to take any picture. They can put it to the turn on the cameras.
Oh,
and
they can look at that.
If you want to. If you want to.
Pictures, guys. And you don't have to show me your face or your background. Just open your camera. Just raise your hand if you're willing to show me. Shay, you know I'm counting on you there.
And
Open
Campbell.
your camera and just show me a sketch of the information that I would have given you here.
Hold on, miss, I'm going for my ruler.
All
I'll
right.
look at you.
He's going for a ruler.
Look at you.
It doesn't need a ruler. You can just, it's a sketch.
Actually,
You don't
yeah,
need
it's a
a
sketch,
ruler.
it's a sketch.
Come on, guys. Tasha Lee has her camera open. Let us look at Tasha Lee. Can we make Tasha Lee the main focus? Can we pin her so everyone can see her?
And I hope that the measurement is on our sketch.
I see
So
some.
it
I
doesn't-
see
it
some
doesn't need a
writing.
ruler, but I'd
I
like
see
to see
some
the measurements
writings.
on it.
Oh, Mrs. Williams, could you spotlight what's her
Lee.
name? Tasha Lee for me, please?
Thank you so very much, Tasha Lee. I appreciate you opening your camera for us.
Will do. Where's Tasha Lee?
Oh, the host, only the host can do that. Sorry.
She's looking for Tasha Lee.
Yeah.
Is it Tasha Lee or Tashelle?
Oh, it's
Tashelle.
Tashelle. Oh my.
Yeah, man, she can be pinned. She's
Oh.
pinned.
I just did it.
She's
Sorry.
pinned?
Yeah.
All right. I don't see her pin, but all right, you say so?
It's spotlight. It's spotlight.
All right, so everyone can see Tashelle's how do I change from Tashelle to, oh, I see it. So okay, so let's Tashelle, you're right there. So it says the rectangular field has a length of 100 meter. I love the fact that your 100 meter length is longer than your 33 meter. Awesome job. How far is it from one corner of the field to the opposite diagonal corner of the field? I want you to put in a line to represent that information. And then you can go back to your drawing. Anyone else feel like they would like to share? Tell you guys already, you know, it's way more interesting when you guys participate. Sabrina, I haven't heard you from morning. Are you there? Just say yes.
Or you can give us a thumbs up, a reaction,
Yeah.
if you don't want to speak in the chat.
Joshua Smith. Someone's
Did-
there for Smith.
Did
go ahead.
Tasha Lee,
She didn't put in
for the line as yet?
the diagonal. She's-
it.
Oh,
Okay,
you tried it.
awesome. It
Okay,
don't have to be perfect, just put in it. All right. Look at you.
Mm.
Awesome job, Tashelle. Thank you so very much for sharing. Really appreciate that. All right, guys. Okay, Shay, go ahead, Shay. Open up your camera. Thank you so much, Tashelle. Shay, could you spotlight Shay? All right, Shay is right there. And we see the rectangular field and we see 100 meters up top. And we see 33 meters to the right side. And we see her diagonal line. Awesome work, guys. I really appreciate you guys. Awesome. So let's look at my sketch. So my sketch is a little bit more fancy, but we get the idea, right? My sketch is missing some information though. What information is missing from my sketch?
The length.
Excellent. The lengths are missing, and that's important. So let's go to the next slide. So here we are. First thing, whenever we're given any problem, we want to understand that problem. And how we understand that problem, we rewrite the question as a statement. Go ahead. So you really want to know what you are asked to do. You're asked to find the distance from one corner of the field to the opposite diagonal corner of the field. All right. So you have that in your head because now you understand what you're asked to do. Continue. What are some of the important information that you got from the problem? You want to know that. Go ahead. When the diagonal is drawn, what do you notice? All right. Let us go. So some important information. We could also look at some important information would be the lengths that were given. Go ahead. So when the diagonal is drawn, probably I should have asked you guys before I put it on the screen, but yes, everyone clearly sees that you have two triangles. Now, information that is not given, but it's a fact that the field should have 90 degrees corners. A football field should have 90 degrees corners. So that information being put out there, you now know that you have two right triangles being formed if you were to put a diagonal as Tashel and Shay had done on their diagrams. Let's go. So here is a better diagram.
I think Miss Harris raised her hand.
Go ahead, Miss Harris.
Just a quick one, just for them to remember, if they were pointing out the 90 degrees point, the question I believe said a rectangular field. So they need to bear in mind that since it's a rectangular field, even if they don't say anything about the right angles, the fact that it says a rectangular field, did it say rectangular field? I think
yes,
it did.
It did. Thank you. It did. Thank you
if
so
it says
very
a rectangular field, it must mean that all four corners are right angles. So they would know that they're dealing with right. When they split it, they're going to have right triangles. So that's something that they will need to bear in mind. You might not say 90 degrees, but you need to be bearing in mind the properties of that right angle, of that rectangle rather, and the fact that all corners are right angles.
Great. So that just reinforced, thank you so very much, Ms. Harris, reinforced that concept learning math integrates into other things. So the fact that you know the properties of a rectangle, you know if a field is a rectangular field, it means that the corners are 90 degrees because a rectangle has 4 90 degrees angles in it. Awesome. All right. Yes, Javon. Continue.
Oh, so what does the diagonal line segment represent?
Oh, yes, I didn't ask that, did I?
Any takers for that one? You can type
They
in
know this. Open
Let's-
up your mic and just say it, guys. I know you know this.
If you think typing is faster than talking.
You see me trying to get them to talk.
Yes, we all see you. Any suggestions? What does the line segment represent? The distance? Shay said the distance. Anyone else? The distance from one corner to the next. Anything else? Anything else you want to add on to that?
Does the fact that you form two right triangles add anything to your question at all, students?
Bring it a little closer to the theory that we're looking at. Pythagoras theorem. What is that?
Raised her hand. Sorry. Chanel, raise your hand. You want to speak, Chanel? I'm going to unmute.
Is it the hypotenuse?
Chanel just said it's the hypotenuse. Good. That's good. So it is indeed the hypotenuse. So the segment between the two corners is the hypotenuse from both triangles, right? So yes, your answer was correct, Chanel.
Right. So from looking at the information given in the question and the sketch that you would have made, all of this would have come out to you, and it would definitely help you in understanding the problem that you have. Continue. So the sides of the fields, so added information, I thought I was finished, but no. The sides of the field are the legs, and the dimensions are given. So you have 33 meters long for the shorter side, and then the 100-meter long for the other short side, just longer than the 33. Go ahead.
We want to put all this information on a diagram, just like what Tashel did and what Shay did. You want to have a diagram for this information that was said in the statement previously. So that's our little diagram right there, right? And we have the hypotenuse, which is the diagonal between the two right triangles. As you can see, the right angles being shown on the diagram. And even though Shay had some, I think two persons had the 100 meters at the top. Remember that the both legs are the same, as in both legs, up and bottom would be the same, right?
So we go back to the properties of rectangle, that the opposite parallel sides are equal in length. So after we understand the problem and we make a list of all the information that's there, whether we use a sketch, so it doesn't have to be that you're writing down this information, you know. It means that your information, your important points can be seen on your sketch, okay? Now we make a plan. Now this is not a very long process, guys, because we don't expect you to do this distinctly like this, or is distinctly? Yes, or spend a lot of time doing it, but this is the process that your mind is going through as you solve the problem. So you're making a plan now. Continue. So here we are. You are asked to find the distance from one corner, the diagonal distance from one corner to the next. So you have to find that length there, which is the hypotenuse. You now know, because you are such an excellent math student, you know that right away Pythagorean theorem plays an excellent role right here in all your skill set as a math student. So you pretty much go to Pythagoras. And what do you do here? You solve. That's it. So you write down Pythagorean theorem first, which says the sum of the square of the two shorter sides will equal the square of the longest side, which in this case is the hypotenuse that we're trying to find. So now let's look at our diagram. We have 100 meters down by the base there, and we have 33 meters there. Does this matter to us? Or we can just pretty much transpose the information? Open your mics and speak to me.
Miss, it matters.
What matters? Tell me, who's that? Shay?
Tashel.
Oh, Tashel.
Okay, Tashel, awesome. So what should I do?
Miss, square the 100 meters and the 33 meters.
All right, but I'm just asking you if it matters how I labeled it. Would you do anything different with your labeling?
No, Miss.
Or you don't, it doesn't matter, right? Because you understand that my 100 meters at the bottom is also meaning 100 meters at the top, right?
Yes, Miss.
Okay, so I must commend to Shell and Shay, because their labels were a little bit easier to understand. They labeled the legs on one of the triangle, which was excellent. Not that it matters, but if you were, say, showing someone, they could easily see the measures of the two legs of the triangle that you're using. Okay, awesome. So you're going to square 100, you said 100 meters, and you're going to square 33 meters. Great, let's continue.
Oh, and remember that once we're using the Pythagoras theorem, we must have the right angle in that triangle in order to proceed to that step, right? So that's one of the key things as well.
Great. So it's important to put in that right angle just to indicate to whomever is looking that you are perfectly sure that you are working with a right triangle. Or you understand that Pythagorean theorem only works with right angle triangles. Go ahead. So we would have squared 33. What is 33 squared, class? Everyone?
Miss 1089.
All right. And what's 100? What's 100 squared?
10,000.
There you go. Awesome job, guys. So we continue. And we, of course, we're going to find the sum of 1,089 and 10,000. That gives us
11,089.
there you go. Awesome stuff. And of course, we're not asked to find c squared. We're not asked to find the square of the hypotenuse. We're asked to find the hypotenuse. So we must apply our root operation. So we find the square root of both c squared and the square root of 11,089. And yes, Mr. Campbell, thank you so very much. And he remembered to put in his meters. Shay also put in her meters. Awesome job, guys. And our correct response would be 105 point, continue, 0.3, or we can also say 105 3/10 of and 3/10 meters long. Did you hear me? 105 and 3/10 of a meter is the length of the hypotenuse. The distance from one corner, the diagonal distance from one corner to the other is 105.3 meters, or 105 and 3/10 of the meters.
And
go ahead.
Large Fenton, remember, yeah, just a reminder, yes, because the Campbell had 105 and 304 thousandths meters, right? But remember that the answer, well, the question that we wanted to solve, it said that we should round our answers to the nearest 10.
Yes.
That's exactly what I was about to say, Mr.
You
Mimi.
see?
Yes.
I'm so sorry. I did not, if you realize, when I was doing the question, I did not highlight that it must be rounded off to the nearest 10th. Tens. Is this tens? Tens.
10th.
10th?
Yeah, 10th. With
Oh.
a T.
Shall I have something to say as well?
Yes, this is what Ms. Hazel.
Yes,
Go ahead.
I
Go ahead,
didn't know
Hazel.
that almost rounded up to a decimal.
That's my
fault. 105.
That's my fault. So that's another thing we need to pay attention to what the question asks. Go back. I did not. No, you don't have to go back. The question had said, round off your answer to the nearest 10th. So I had kind of skip over it, but it just reminds us that when we're given a question, even when you finish working out, look at your original question so that you know what, because sometimes if it's a multiple choice, you may not see your answer appear because they want it in a particular format. And if it's a structured question, they may want it in a particular format and you lose a mark because you did not round it off correctly. So just remember, guys, pay attention to what is asked.
And remember to read the question more than 2 times until you understand the question. Then you can make the plan, and then you see what mathematical concepts or tools you can use to solve the problem. So we use Pythagoras theorem, we use addition, and we use a square root sign or symbol, sorry, to evaluate and to get our final answer, and then pay attention to what our answer should be in, what value our answer should be in, the units, and whether it's 2 decimal places to the nearest whole number, to the nearest 10th, to the nearest 100th, to the nearest thousandths, whichever one, you need to make sure you read the problem or question at least 2 times until you understand what you need to do. And then it divides the plan and so on and so forth.
Right. So just as Mr. Limi said, understand your problem, pay attention to the key information, make a plan, solve. Yes, let's continue. All right, here we are now, math and baseball. Now, I know that baseball isn't a sport that we are often playing in Jamaica, but guess what? I don't think anyone just plans to stay in Jamaica for their entire life. You probably will travel somewhere, and knowledge is important. So let's just look at the baseball pitch here. Let's continue. So a baseball diamond is really a square. All right. Now let's look why it's really a square. If you can tilt your head, you'll see it. But let us look at the properties of the baseball diamond, as they would call it. You have 4 equal sides. You see the 90 feet, 90 feet, 90 feet, 90 feet. And all the angles are 90 degrees. That is what makes it a square. It has 4 equal sides, and it also has 4 90 degrees corners. All right, let us continue. You can use Pythagorean theorem to find distances on a baseball diamond. Let's look at that.
And remember, you must pay attention to the little animations that are actually taking place in order for you to understand the question a bit more, since we're not familiar with the game of baseball, right? So just look at the diagram. Once Mrs. Lodge Fenton is speaking, look at the diagram and see what moves and see what you can garner from that image or diagram.
So here we are. The distance between consecutive bases. Consecutive bases means second base. The next base after second base would be what, guys? This is easy stuff. Open your mic. After second base, you're clearly going to go to? I'm not going to talk to myself, you know?
Third base.
Excellent. Thank you, Shay. We go to third base. So consecutive mean what comes next? So you have your first base, second base, third base, and after third base, you definitely want to go home, and it's called a home run. Awesome. See, you get some baseball info right there. It says, how far does a catcher have to throw the ball from the home plate? You see the home plate pop up to the second base. There you go. So what are we trying to find? We're trying to find the distance from home plate to second base. All right, before we give anything else, I want someone to either type it in the chat, since I'm always asking you to talk. I do prefer you to talk. Tell me, what would you do? How would you approach this problem? You don't have to be long. You don't have to be systematic. It has to be systematic. Tell me how you'd approach this problem if you were asked to find that distance from home plate to second base. Lovely. Use the ruler. And okay, that's a good one. So Shay said you should use the ruler and measure the distance. Awesome job, Shay. But I mean, in real life. So this is a diagram representing the thing. And if it's not drawn to scale, it wouldn't be exact. If it is drawn to scale, however, you definitely could use the ruler and see what is the scale if the scale is given on the drawing. But since there's no scale given, so we don't know what 1 feet represents on your ruler, because I'm sure we can't draw a 90 feet diagram in your book. So what information, what concept we are now quite clear on, or we are exploring, that could help us to find the distance? Oh, the chat is... If I'm missing stuff in the chat, guys, feel free to come in.
Oh, Tashel just said fine. Sorry, Tashel just said fine half of the square, I guess.
Tashel, you know, I appreciate your input, but I don't want you to guess. I want you to tell me. I want you to be confident in your information. Tashel, open your mic and talk to me. Michelle? Okay, explain us a little bit more. Find half of the squares. I see what you're saying, but I want you to explain a little bit more.
Miss, add 90 plus 90.
Okay. Is that what we've been doing? We've just been adding the value of the sides?
Miss, and square it. 90
okay.
Square plus 90 square.
There you go. So you see, just organize your thoughts. Great. So what concept are you using here? What math concept are you applying?
Pythagoras.
Great. We're using Pythagoras theorem. What do you know about Pythagoras theorem?
The hypotenuse is the sum of the two sides.
You're missing something though. The what of the hypotenuse?
Square.
Yes, the square of the hypotenuse is equal to the square of the
Length. The two lengths.
of the other two lengths, right? And you also have to make sure you have. Go ahead, Carol.
I was just commenting on including the lens. That's all.
Okay.
Mhm.
Okay. So you also have to remember that once you have a right triangle, that means once you have a triangle with a right angle in it, you can always apply Pythagoras theorem if you want to find the length of a side given the length of the other two sides. Doesn't matter which two sides are given. Okay, so thank you so very much, Tashelle. So let's just help clear that up now, or help formalize what Tashelle said. Thank you again. So here we are.
Before you go there, Mrs. Lodge Fenton, just you can keep that diagram up. Just a line of thought. I think I'm drifting way off course.
Sure.
But I would just like someone, they can type in the chat to tell me where I'm off and what I'm saying wrong. Because in my mind, I'm saying if I have 4 lengths like that, suppose I add those 4 lengths, what does that represent? I think I'm off, but somebody want to tell me, what is it? If I add the 4 lengths, that would be there, which would be the 90 feet, the 90 feet, the 90 feet, the 490 feet. What would I call that? What would I define?
The perimeter.
You.
Very good. Right.
Awesome.
So if I would like to find the perimeter, I'd add the length on the perimeter of the shape. Very good. And I will hand back to Mrs. Lodge Fenton in a little while. The question says to go from home base to second base, and she labels it as C. And she also told us earlier that the baseball diamond, which I'm not familiar with, so thank you for that information, Mrs. Lodge Fenton. The angle, each angle in the baseball diamond is 90 degrees. So I understand that the angle at third base would be a 90-degree angle. The angle at first base would be a 90-degree angle. All of the angle at second base is 90, and also the home base angle. But I've drawn a line there. You can take back over, Mrs. Lodge Fenton.
So since we went off on a tangent, anyway, let's just continue in tangent and then come back. So if I draw that line, and I'm going to use my words carefully, if I bisect the second base and I bisect the home plate with that line, who can tell me the angle of the other two, the size, the measure of the angle at, you can point, you can use a pointer and put right on this side over by the second base? How much is each of the angles at second base? The 2 halves down that I have.
So the entire angle at home base is 90. And I have shared it. Would I share it into 2 equal parts? Would that be a property of the square? That if I draw a line along the diagonal like that, I would divide it into 2 equal parts. I also see another answer there in the chat. You can take it back, Mrs. Lodge Fenton.
Okay. So what I wanted you to see is that when information is given, it tells us so much about the question, and it gives us ways to interpret the information. If I dissect the 2 angles, that means my angle in my triangle on the right is 45 by the second base and 45 by the home plate, because 45 and 45 makes 90. And when you bisect something, you cut it in half. Please pick up, Javon. Just give me 1 moment, please.
All right. What was she alluding to earlier? She said something about bisecting.
Sorry, I was coughing. I'm so sorry.
Oh, sorry.
All right. So we have here, so let's go back to the original problem. Tichelle had said that we would square the 90 feet, sum them, and that would help us to find the distance from the home plate to the second base. Let us look at that. Continue. And Dijon, please remember, when you give me any answer, I need a unit attached to it, sir. So the perimeter, it cannot be 360. Is it 360 ducks, 360 horse? What is it? 360 what? So here we have to establish, we have to just remind ourselves of the relationship that exists within a right triangle. And that is a square plus b square equals c square. So we have 90 squared plus 90 squared equals c squared, and we square both the 90s, giving us 8,100. Then we sum those two values, giving us 16,200 equals c squared, where c here represents the hypotenuse, which is also the distance from home plate to second base. We find the square root of both values there. The square root of c squared gives us c. Square root of 16,200 gives us
127.2 feet.
By awesome job. Great job.
I hope the students are checking by using the calculator. Practice the use of the square root sign on the calculator and get the answer. The question did not indicate to how many decimal places. So I think for CSEC, it says if it's not stated, it's 2. Is that so? If nothing is said, you correct to 2 decimal places.
Oh, it's normally 3 significant figures.
3 significant figures. Okay.
Yeah. The normally it's 3 significant figures, yeah.
Right. So instructions like those would be on the front cover of the front inside cover. Is that correct? Not the cover page on the outside. There are some instructions on the inside, some general instructions. You can look for that.
Oh.
And it tells you what to do if the rounding off is not stated in the question. Okay, keep going. Hand back over to you.
Okay, I got okay. So here we are. So the distance from home plate, and we got that. Perfect. So just remember, in the previous exercise, there are only 2 scenarios that will present itself where you will require the use of Pythagoras theorem. And this is, which scenario is this? 1 or 2? Somebody.
I think it's scenario 3.
Scenario 3?
Scenario 1 or 2, and you say scenario 3?
It's not 3. It's either 1 or 2.
No, because scenario 2 in my book is the one with the one leg and the hypotenuse.
Yes, and scenario 1.
What is scenario 1?
Oh, okay.
Yes.
My bad.
That's okay.
Okay, great.
You guys. All right. Sorry, I had to close the device. All right, here we go. So we are at the ladder problem, or we can call it Pythagoras at home. All right. So a ladder leans against a second-story window at a house. If the ladder is 13, it should say 13 meters long. Campbell, you realize how important my measurements are? My units are 13 what long? 13 chicken foot long? I need to put a unit. So the ladder is 13 meters long, and the base of the ladder is 5 meters from the house. I hope you're all envisioning this diagram in your head. How high is the window? Now, before we even touch the question, what are some properties of a house and a wall and the ground that is important here? Or that we're pretty much assuming that the house is built correctly and the land that it's on is a particular way. What are we assuming here? Campbell, you can type it. I'll read it because you don't like to open. From more, you don't open your mic for me.
And you can always sketch a diagram to see
Sure.
what you're actually gonna do. So pretend you're actually putting the ladder on the side of the house and you're putting it towards a window, right? And then you have the base of the ladder from the house.
Right.
Draw a diagram, sketch a little diagram. If you have it in your head, it's just for us to actually put it on a piece of paper and then proceed afterwards. But continue, Mrs. Lodge Fenton.
All right, so I wanted you to realize that some things we can't take for granted. We're going to assume that the house is built correctly on a flat land and that the distance, the 5 meters is on a straight plane and that the ground right up to the wall of the house, it's going to form a 90 degrees because that's how houses should be built, right? Doesn't always happen, but we're taking those things, we're taking them for granted. We're assuming that all is well with the house and the land. So now, that being said, let's put this information on a diagram. Tishelle, I know you like to draw. You have anything you can show us? Or should I go tonight? Okay, awesome. Open your camera and show me. Shay, you know I'm not leaving you out. Mr. Campbell, any diagram?
And even Chanel.
Chanel. Denise, you're not saying anything. All right, Tishelle, I can see you. Look at you. All right. All right, awesome. So I see you have the same diagram, a similar diagram to what I have. Chanel, great work over there. I am seeing your house. What is that? Chanel, Tishelle, I want you to put it in a, give me a no. Chanel, I'm going to come back to you. Don't think I don't see you. Tishelle, I want you to now take that and put it into a triangle for me. Just see if you can use what you have and draw a triangle to represent the ladder, the distance from the house, and the wall of the house. Chanel, let me see back your diagram. All right. So what I want to see, Chanel, what is that thing you have? What is your label? Right.
I think that's a hypotenuse.
She put the hypotenuse there. Okay, so that's your ladder. That's what I want you to do. I want you to transpose the information that you have. This is your ladder. What is the length of your ladder, Chanel? Open your mic, please. What is the length of the ladder? Okay, Chanel, but just go ahead.
So the ladder would be 13 meters.
Very good.
That's the hypotenuse.
Uh-huh.
And the width, that's from the ladder to the house, that would be 5 meters.
What did you call that measurement?
The width, not the width. Like this, let's say B square would be 5 meters.
B square. All right. Oh, B, you said B. Okay. You're putting it in. Okay. You can always say the distance from the house, though. The distance from the house to the bottom of the ladder. That's fine. Okay.
And what would be on that right side of the triangle, the side that you don't have anything at? Yeah. What would that be called?
Think about the diagram.
Look at the statement. And look at the statement on the screen as well. What would that be called? That side that you don't have anything for. Think about it.
Michelle, go ahead. Let me see your diagram. All right. So just straighten this up a little. I can't see it. It's not really in. I can't see it very good. Character. Yes. So you have. All right. I guess you're fixing something. Chanel, all we're asking you in relation to the house, what is that side that you haven't labeled?
That would be the distance from the ground to the window.
Very good. Awesome job. Great job, Chanel. Keep doing what you're doing. Tishelle, let me see your diagram. Where is Mr. Campbell? I don't hear anything from him. Him typing in the chat?
He said his camera on his laptop is not working right now.
Nice fruit punch with a nice. I don't hear Tiana today.
All right. What I must ask you, Dejay. You agree with the diagrams that Chanel and Tishal have?
Yes, miss.
Okay, he opened his mic for me.
So I was open my mic, you're just probably not hearing me.
Sorry, that's so great. Nice to meet your voice.
Miss, I thought before, but you probably never heard me.
I heard
Okay,
him
then,
once. I heard him
awesome.
once. So.
All right, Tishel, let me see. Okay, so can we spotlight Tishel? Because I'm having a little issue seeing. Tishel, just walk me through your diagram. What do you have at the base?
This, the 5 meters.
Yes, and the side you have
Yeah, she has a 13. Yeah.
13. And then, so we have the side similar to what Chanel has, that side from the base to the window.
Yes, miss.
Okay, and thank you so much. Those diagrams are right on spot. You agree, Mr. Lime?
Yes, they are.
All
And
right,
they
great.
give us the side that they never had, the description for the side that they don't have, which is what we want to find.
Exactly. So we want to find out.
From the ground.
Right. We are definitely trying to find out how high is the window. All right, from the ground. And ladies, thank you so very much. Let's continue, sir. So here we are. First, we draw a diagram that shows the sides of the right triangle, which we just saw Chanel and Tishel do. And this is another way you could label it. You could definitely put the height of the window. So you don't have to try to force yourself into putting in the letters right away. You can just pretty much draw a triangle to represent the information that you have and label it with what you have. And then you later can plug in the letters and whatever you need to make this work. Continue. So we label the sides. The ladder is 13 meters. We know that. Distance from the house to the ladder is 5 meters. And now we can use a square plus b square equals c square to solve the missing side. All right.
Tishel raised her hand.
Go ahead. Go ahead, Tishel, you can speak.
I don't really remember how to calculate it, but miss, would that be like angle of depression or elevation?
Oh, well, you know, that's a total different topic, but I'm glad that you are paying attention to the concept that may be brought out by a diagram like this. But you would have, if you're talking about the angle of elevation, you would have been looking at something if you are
at the base. Or
if you're I'm trying to figure out if you'd be in the soil, you'd be in a hole in the ground, looking up at the window.
You'll be at the base of the ladder, looking up to the window. And then
so that means they would have dug a hole and you'd have been looking up from the hole in the ground.
And then even when they're at the top of the ladder, where the window is, they're looking down, so that's the angle of depression. So angle of elevation is equal to angle of depression. And we can continue after that.
Okay.
All right. Go ahead. All right, so now we have the formula. And of course, we already made it very clear that the two shorter sides, you do not have to dictate. There's no definitive rule, which is A and which is B.
And which scenario would this be? Would this be scenario 1 or scenario 2? And what computation would you actually do? Because we had summaries for the two scenarios. What computation would we actually do? Which scenario first? Which scenario would this be? And what would we do after?
Would you add or would you, what's the other one?
Subtract.
Okay.
The opposite of adding is subtracting.
Okay.
Subtract.
All right,
right.
subtracting. And which scenario was this or is this?
And there's only 2 scenarios. Let me just throw it out there.
Not 3.
Scenario 2.
All right, fantastic. we can continue now.
All right, so here we are, and we would have subbed our value into the equation, and you would have, so we have a squared plus b squared, and in this situation, b is 5. Right, so we have 5 squared is 25, and then we have c squared, which is the hypotenuse, which is 13 squared, which would be 169. And of course, we are going to simplify our equation until we end up with a squared being the subject of the formula, or better yet, I should say a being the subject of the formula, where we have a value for a, because that's what we want. We want to find the length of the distance from the ground to the window, the height of the window. All right, so here we are, we would 25. So first we'd have a squared plus 25 equal 169. We want to simplify that. We want to, so 25 subtract 25 gives us a squared alone on that side, and we'd have to also put on the other side of the equation. So 169 subtract 25 gives us 144. We'd find the square root of a squared and the square root of 144, which I am sure everyone knows how to plug this into a calculator now. And the square root simply tells us what number you'd multiply by itself to give you back the value that we would have found the square root of. Go ahead, Mr. Lee.
And before we continue, Tamika, we must actually add that when you find the square root of 144, it can actually be two answers, negative 12 or positive 12. But since we're actually doing length or distance, we don't have negative 12 meters, right? So this is why we always go for the positive aspect of the number once we are doing measures of length and so on and so forth, right? So the actual square root of 144 is actually both two answers, negative 12 and positive 12. Because when you go into other topics in mathematics, you'll discover that that's actually true, right? But again, the reason why we don't look at the negative 12 meters, because we don't have negative 12 meters, right? We only deal with the positive aspect once we're dealing with the Pythagoras theorem for the dimensions of length and so on and so forth. So that's the only thing I would like to add in that.
Right, so we have A is now A being the height of the window. All right, moving on. All right, so here we are. Now, I want everyone to look at this with as open mind as you can possibly do, because math is easy. I can do math. That's something that everyone can do. So let's look at this question. Go ahead. You're asked to find X and Y. Now, which of the values should be first and why?
Miss, I
Yes.
think that you should find Y first, because you can't find X unless you know what Y is, because Y is the opposite for A, but it's also the hypotenuse for B.
All right, so I see you're using some other knowledge. I see you're mentioning the term opposite, which comes from trig ratios. So good that with trig ratio is out there, you know it's out there, but we can't use the word opposite here. Why we can't use the word opposite? How do you know that a side is opposite? What do you use to tell you the side is opposite?
Miss, I just tend to look at it, and if it's like straight, I call that the opposite.
All right, so what happened? But let me just add to your knowledge there. When we're identifying opposite and adjacent side, where we have an angle that we're using. So because there's no angle here, we really can't refer to a side as an opposite. But your first response about finding Y first merits to that you are correct with. We need to find Y first, but I want you to look back and tell me why. Why should be found first? Just look at it. Remember, you can't say opposite or adjacent. You just have to look at what you have, look at your two triangles. Why is it that Y is the better side to find, or the possible side to find?
Right, so
Sure,
Tasha
yeah.
has a raised hand.
Mhm.
Miss would find Y first because we have both legs, and only for the X part we only have one leg and no angle.
You couldn't have said it better. Excellent job. Because we're using the Pythagoras theorem, and the concept talks about the relationship with three sides. Triangle B, where Y is the hypotenuse, has the values or the length of the other two sides. So given the two sides, we can now find the two shorter legs, we can now find the hypotenuse. If you look at triangle A has two unknowns and we have no angle. So although trig ratio is out there to use, because we have no angle, we can't refer to that. So we only can apply the Pythagoras theorem here, which would indicate that Y is the best one to find first. Someone else was saying something? All right, let's continue, Mr. Salimi. Where are we in time? Okay. All right. So here we are. Of course, you know, you want to remind yourself, refresh yourself of the relationship that exists within right triangles. A squared plus B squared will give us C squared, where C is the hypotenuse. All right. And we are simply going to solve using triangle B to find the value of Y. Go ahead, sir. So we substitute our values in. The shorter sides that we have are 4 units and 6 units. So we put them into our equation and we solve. 4, 4, 16, 6, 6, 36. However, what if we didn't solve those? What if we did it this way? Am I correct? Can this be done? Here's what time we break again. What time is it?
Yes, miss.
We break at 11. Just an introduction here. We will break at about 11. The link to the Miss Williams, is that the link to the
Yes, the
evaluation?
Yes, it is. As well
The link to
as
evaluation is in the chat, and you will also get the link to the lunchtime work. Sorry to disturb you at this time, but the evaluation, we like you to evaluate the session as soon as the session is over, and take the link for the lunch work and look at it during the lunchtime. Continue.
All right, guys. So somebody had said yes. Was it Shay or Tishelle?
I think it was the shell.
Okay, great, thanks. So as you can see here, guys, we can definitely work it this way. We don't have to always find the value of the square first and then add it. We can put it, we can just write out the square root of it, and we can write it down like this. Now let's explain why. Continue, sir. So we would have already known that to find Y, we'd have to find the square root of Y squared. And we'd also have to find the square root of the sum of those two values. So we're pretty much preempting what we've done so far by putting the square root up first. So the square root of 4 squared plus 6 squared would give us, so we'd have 16 plus 36 gives us 52. So we want to find the square root of 52. No, we can definitely find the square root of 52. Continue, sir. Okay, and it would have been 7.21 or 7 21 hundredths units. And this is round off to the second decimal place. So it is also important that you note where you would have round your answer off if it is required. or if you just want to make sure that they understand where you're coming from. But what if we left the value of y as the square root of 52? How could we write this as an equation? Quickly, guys, because we are coming to the end of our presentation. If I didn't find the value for the square root of 52, but I left it at the symbol square root of 52 and put it on the diagram. Sorry, did we eventually put it on it? I don't want to move and assume. I don't want them to see the value.
Yes,
Write me an equation.
We actually
with
use
not,
root 52. We actually use root 52.
all right. So
It's actually indeed
before,
52.
write me a quick equation in the
Chat.
in the chat. You don't have to worry about finding a symbol to represent 52. Just put, I don't know. Put what I can use.
You
Because
can
I
use words, square root 52.
okay, just put root
Word.
square. Put
Or even root
SR,
52.
just put SR 52 beside it. So I know you know it's so write an equation. If you had the square root of 52 where y is now, write it in terms of x. How would you find x?
The X in triangle A.
The x in
Miss, you
triangle.
can type it in the chat.
Of course. Go ahead.
Of course, why not?
Mr. Cam, you're working on it as well for me?
Yes, miss.
Okay, awesome.
The others like Denise Williams, Joshua Smith, Kelly, Sabrina, T-Man. So all of those persons and Latouche.
They've just been silent from morning. I wish I could see them.
And Anna Hayden.
Okay, what happened to you guys? Say something to us.
Even if it's to say hi.
We'll appreciate the hi. Okay, somebody says I'm here. Latouche, hi, that's great. Glad to know you're there. And I hope you have learned something. All right, I'm not seeing my chat blowing up. Campbell, Shay, Tishelle. All right, great. I'm glad that you learned something, Latouche. I'm so proud. Okay, awesome, Shay. Thank you.
Oh, we're waiting on the
My equation.
Yes, the equations. And you can always write them, write them in your books and then open your camera and show us.
That too. So just to help you go along, remember we would have been doing Pythagoras theorem and we've been, okay, Tishelle says, so x squared is equal to a squared plus b squared. All right.
And then x squared is equal to 7.21 squared plus 12 squared. Then she added those and then she square root them. And she got 13.99 and she rounded it off to the nearest whole number, which is 14.
Okay.
And what's the units? What's the units that we should use, Tashelle? Okay. All right. You missed out that part and he gave us. Okay. So she was saying that she missed out the x squared is equal to the total, which was 195 and 98 hundredths. And then she squared out that value. She got 13.99 and then she rounded off to the nearest whole number, which she got 14. And units, remember the units now, Tasha?
So we just use the word units here because we didn't attach any units to the original diagram.
Yes. So that's actually correct, I would say.
Yes, it is, but I still wanted to see within the answer square root of 52. I wanted her to include it.
To use the square root of 52.
Right. So that's what I wanted her to show me. So because I want you to understand that it doesn't matter what the value is for any of the side, you can plug it into your equation just the same. So where Tishelle has 7
Point two one.
and yes, 7 and 21 hundredths. So 7.21, you could have definitely just put the square root of 52 right there. So that's all I wanted you to, but thank you so very much to Shell. So guys, as long as you find y, it can now help you to find x. So you will have questions like that you will have to determine which is the best one to find. And using that value, it helps you to find the other side. All right. It doesn't mean it's difficult. It just means that you have to look at it and reason it out correctly. Now, as you can see, even if the diagram looks distorted to you, the fact that those two little squared things is in the corner, it tells you that you're working with the right triangles. And when you're working with right triangles and given any two sides, you should know right off the bat to find the missing side. Pythagoras theorem is an excellent option. If an angle is given, then you can definitely think about the trig ratios. And the trig ratios we will have to do in another series of our Region 1 Math CSEC camps. So I appreciate, sir, we have another slide after this?
Yes, we do.
Right, so there you go, the y equal the square root of 52. Right, right, go ahead, sir. So I just wanted you to just plug it in that way. Go ahead. So that's all I wanted you to see. Now, when you plug it in this way, I want you to understand what the square root and the square means. So the square root is the opposite of squaring, and squaring is the opposite of the square root. So let's make it even simple. What is the square root of 4? 2. And if you square 2, you get 4. So if you're doing both of them to the same value, what's going to happen? Next line, sir. You're pretty much going to just come back to your original value. So if you find the square root of 52, it gives you a value, then you're going to square it. So you just undid the square root by squaring it. So it comes back to 52. I just want you to know that in your head. So if you were to find the square root of 144, it will be 12. And then when you square 12, it would be 144. So all I wanted to point out is that the square root is the opposite of squaring. And when you're doing both functions, it really just keeps the number the same, the value the same. All right, whether you found the square root first and then found this, and then square it, or you square the value, and then you found the square root. Yes. So here you have x is the square root of 196, and that is 14 units. And that would give us the value for x. So doing those two little things, you would have found the value for y and x. All right. So in summary, there is a relationship that exists with all three sides in all right angled triangles, or commonly called right triangles. The sum of the square of the two shorter legs is equal to the square of the longest leg, which is called the hypotenuse. And we write this using symbolic representation, a square plus b square equals c square, where c represents the hypotenuse. Continue. Here we go. Continue.
And that's really it.
Right, so the area of C is equal to the area of A plus the area of B. Because when you squared it, you would have looked at the area of the lengths of those sides, using the lengths of those sides. So of course, if you had a leg measuring 3, the square of 3 would be 9. So the area of that leg at B would be 9 square units. And the area of the A, if it was say 5, would be 25 square units. And of course, you would add those and you would get whatever. I'm just randomly using some units now. So just remember, C squared is equal to A squared plus B squared. Thank you. All right, guys, I really appreciate you guys staying on and participating. Please do click on the evaluation form first in the chat and fill that out for us. And then you guys can go and take a break. What time do we come back, Mr. Limi?
Oh, before they take the break, well, they will, sorry, go ahead.
Yes. Continue, Hazel.
All right. Right. Good afternoon and good morning again, everyone. So we'd like you to do the evaluation. It is pasted in the chat. And in addition to that, you will have some lunchtime activity to do, a few questions to look at during the lunchtime. So it's a 2-hour break to 1 o'clock. Okay, please, we're asking that you take some time to do the exercises, and we'll meet you back at 1 o'clock. You'll have the same presenters. Do the evaluation, do the lunch exercise, and also get some lunch and relax a bit. That's it from me.
Thanks, Hazel. So we'll cut it right there for now until 1 o'clock, everyone. So thanks for participating, and we will see you at 1 p.m. sharp.
Right. So, guys, we're going to work more questions at 1. So please come out with your books and your paper and your pens and your calculators to work questions. And you know we're going to have fun. We're going to pick on everybody that's in the group. So please come prepared to open your mics and speak.
And one more thing before we leave, we have the YouTube channel, our Region 1 YouTube channel, which is, you can find on YouTube, which is Region 1 Maths Team. And you can always like, share, and subscribe, and share it to other students like yourselves and your friends, etc. Where you can find the other presentations that started from Tuesday, from statistics. What was the other topic? I literally forgot the other topic. Coordinate geometry and statistics. So you can always check out those sessions. We have both the tutorials and the teaching sessions from the morning and in the afternoon sessions. So that's really it for now until 1 o'clock. That's until that time.
Just to interject, remember to like and subscribe on our channel.
And remember, guys, if we were going a little bit fast and you missed a point, or you wanted to review something that we did, whether it be today or the previous days, you can always go on the YouTube channel and view the presentation again and slow it down to your liking. And for your friends who were unable to attend, you can always just send them a link that the presentation is online, and they should like, subscribe, and share.
See you after lunch then.
Did you guys complete the evaluation forms?
Yeah, remember the evaluation forms.
Please respond.
It's in the chat.
Finish. Campbell?
Oh, remember that we're still live, by the way.
I'm doing it. No, I didn't start as yet.
All right, start it now then.
I'm going to. Okay.
All right,
Thank you, I appreciate it.
Okay, thank you so very much.
Mrs. Williams, Simone Williams, can you end the stream for us, please? Because I can't end it as yet.
So guys, go on the evaluation form and do that. That's the only way we know how to help be better at what we do. So we need to hear from you guys.
So waiting on Miss Williams to cut the feed because it's still live. So yeah.
So guys, feel free to sign off once you have done evaluation. Feel free to sign. Please, before you sign off, click on the Google Docs for the tutorial. Is it the link to the tutorial?